Alright guys, congratulations. Once again, you've reached VOD 4 for Unit 2. Okay, today we're going to be discussing chemical and physical changes. Up to now, we've discussed chemical and physical properties, things like density, states of matter, that kind of stuff. Okay, today we're going to get into what happens when these properties change. Okay, a little bit different stuff, and it's going to build well to where we're going with this concept of chemistry. Okay, so first of all, let's talk about physical changes. The substance doesn't change its chemical composition. Okay, so when we're looking at the atoms, they may rearrange themselves, but they are still the same. Okay, so for instance, this frying pan down here in the corner. Everyone's seen the strongman demonstration where they roll up the frying pan into a burrito, right? Well, the frying pan initially was a frying pan and still remains a frying pan. Okay, with a lot of force and a lot of serious strength, you could probably flatten it back out and make the the frying pan normal again. And that's an important trait to note about physical changes also. They can be reversed. For example, there's a number of them, but tearing paper, dissolving salt in water, melting ice, freezing helium, things like that, okay? Changes in state are physical changes. We talked about that earlier, correct? Okay, so one of them that I kind of haven't harped on as well as I probably should have is dissolving salt in water, okay? Dissolving anything in water is a physical change, not a chemical change, okay? If something is soluble, it is a physical property, but whenever you dissolve the salt in water, it is a physical change. You're not changing what it's composed of, and if you dried all the water out, you could regain the original stuff, okay? It is reversible, okay? Physical changes are reversible. Okay, so that is a prime example of a physical change. Okay, Optimus Prime, who is disguised as a truck on Earth, right? He transforms into this giant robot. Okay, initially he was a truck, and his end state is that he's still Optimus Prime, correct? Okay, he hasn't changed who he was at all. He's only changed how he appears. And that's a perfect example of a physical change, okay? See the clear distinction there. We're going to talk about chemical changes here in just a second. Chemical changes occur on the molecular level, okay? So we've talked up to now about how all matter is composed of atoms, and the way that these atoms and what these atoms are made of give certain properties like smell and sulfur, or like how it is soluble in water and salt, right? Different types of things like that. And so these atoms they start as one thing, but in a chemical change they end as something totally different, okay? Reactants, what go into the reaction, products, what come out, okay? Now, products are very different from whatever you started with in the case of a chemical change, okay? The end stuff is not exactly the same as the beginning, and that's the way it should be, because we have things like wood over here. We've got this image of wood where it's been being burnt, okay? The initial reaction was taking a log that you would find outside or something like that and throwing it into a fire. The end result is black and ashy, and it has all these burnt texture to it, essentially, right? Okay, now that's important to note because the end result is nothing like the original log that you put in the fire. Its composition is totally different, but also it can't be reversed, okay? You can't do anything to bring that wood back to the way it was whenever you first put it in the fire. Now, there are other examples and indicators of chemical changes are bubbling, change of color, formation of solid at the end. It's called a precipitate. We'll talk about that later. Rusting. Rusting is a big chemical change. When you leave your bike outside for too long in the weather and it gets all rusty, that is a definite chemical change. Something else has come out of the reaction of iron with the air. And cooking, every time you set foot in the kitchen, a chemical change occurs, okay? Whenever you bake a cake, whenever you make cookies, whenever you even cook eggs, chemical changes do occur.
A bit better. Put the egg right into the pan.
And you have just witnessed a chemical change, okay? Initially the egg was fluid and very light in color, and now this light fluid has kind of become more solid and white, and that is the prime example of a chemical change, okay? Whenever you notice a color change from that clear to actual white, that is a chemical change which has occurred in the egg, okay? Whatever is there now is nothing like what was there in the first place, okay? And it's irreversible. No matter how hard you try, you can't take that white around the outside of our sunny side up egg and turn it back into the fluid that was inside the egg in the first place. Now, how do we differentiate between the two? We have physical changes and we have chemical changes, and they're both kind of different from one another, okay? Physical changes are only things like change of state or like ripping these papers, and they're reversible. But these chemical changes are going to give off indicators such as a change in color or a noticeable smell or visible bubbling or fire or temperature increases or decreases, things like that. They're going to be easily noticed in the case of a chemical change. Sorry. If you guys have any questions, please come in for activity period or post them in the comment section below. Otherwise, have a great evening. Thank y'all.